Now in this video, I would like to introduce you with the concept of curves. Now the curves are categorized into three. First type of curves are implicit curves. Implicit curves uses the function fxy equals to 0. This means for same value of x, there are multiple values of y. Second type of curves are explicit curves. The function used for explicit curves are y equals to f of x. Y equals to f of x. This means that for different values of y, there are different values of x. The third type of curves are parametric curves. The function used for parametric curves is x equals to xt, y equals to yt, and z equals to zt, where t takes value between 0 and 1. So you can also see the parametric curves uses the parametric equation only. Now the first two curves, implicit curves and explicit curves, only have two variables x and y. That means they can only be drawn for 2D purpose, whereas parametric curves are used where 3D is involved. Now let's move on to parametric curves. We have four types of parametric curves. First is Bezier curve. Then next is Hermite curve. Then B-spline curves and spline curves. We are now required to do Bezier curves in detail. Now, Bezier curves are further classified into three types. First type of Bezier curves are simple Bezier curve. First type of Bezier curves are simple Bezier curves. Simple Bezier curves, we have only two endpoints, or we can say two control points, and it is a simple line. Suppose I have two endpoints. Suppose I have two control points, not we can also say them control points or endpoints, P0 and one is P1. These are my two control points. So when I join these 2 points, it is a simple line, which is a simple Bezier curve. Next type of curve is quadratic Bezier curve. Next is quadratic Bezier curve. Quadratic Bezier curve have 3 control points, right? So suppose I have 3 control points, say P0, P1 and P2. Now these curves, this is P0, this is P1 control point, and this is control point P2. Now when I join these 3 points, the curve is drawn like this. Like this. This P1 control point is the intermediate control point. From the curve will not touch this point, but it will pass near to this point. And if I draw tangents from P0 to P2, these two tangents of the curve will meet at point P1. So this is how the curve will look like. So please note, the curve from P0 to P2 will not touch the point, control point P1. It will pass with some distance. It will pass through some distance. There will be some distance between point P1 and this curve. Then the last type of curve is cubic Bezier curve. Cubic Bezier curve. Now cubic Bezier curve have 4 control points. Suppose I have 4 control points. Let it be P0, P1, P2 and P3. Suppose this is control point P0. This is control point P1. This is control point P2 and control point P3. Then again, when I'll draw a curve from P0 to P3, the two endpoints, the curve will not touch the intermediate control points, but it will be drawn like this. And if I'll draw a tangent from P0 to P1, it will touch this point P1, and a tangent from P3 will touch point P2. So here in this case, in cubic Bezier curve, P1 and P2 are my intermediate control points. So this is about the types of Bezier curves. Now let us move to the properties of Bezier curve. Now the first property of Bezier curve is that it depends upon the number of control points. Then the second property of Bezier curve is that Bezier curves may pass through two endpoints only and not from all the control points, right? So Bezier curves can pass only through two endpoints and not from all the points. So this is a very important point. Like in quadratic curves, Bezier curves and cubic Bezier curves, you can see that the Bezier curve is passing only through the control point P0 and P2 in case of quadratic, and from P0 to P3 in case of cubic, and it is not passing through the intermediate points, which are the control points. The third property of Bezier curve says that polynomial representation of a curve depends on the number of control points, right? The polynomial representation of a curve depends on number of control points. Like, what does this point means actually? See, for example, if I have n number of control points, then the degree of polynomial equation would be n minus 1. Suppose I have n equals to 4 as control points. That means I have 4 control points. Then the degree of polynomial equation will be 4 minus 1, that is 3. So when the degree is 3, that means it is a cubic Bezier curve. Suppose n is equals to 3 control points. Then the degree becomes 2. 3 minus 1 equals to 2. Then it is a quadratic Bezier curve. So these are the 3 main properties of the Bezier curve. So this is about the curves. I hope you have all understood. Thanks.